For each ionic formula, we're going to identify the group number to which element X, some fictitious element, belongs to. So for ionic compounds, they're made up of these binary ionic compounds. They're made up of cations. Here, group 1 element are going to form 1 positive cations. These are going to form 2 positive cations, and group 13 is going to form 3 positive cations. That all has to do with the number of valence electrons they have that they're going to lose. Noble gases don't form ionic compounds. And going from right to left, group 17, having 7 valence electrons, going to gain 1 electron to form 1 negative anions. Group 16 is going to form 2 negative anions, and group 15, because they have 5 valence electrons, are going to want to gain 3 valence electrons to achieve the octet rule. So their most stable form is going to have a 3 negative charge. These don't generally form ionic compounds. They can form ions, but they don't form ionic compounds. Now, we're going to kind of reason this out here, because calcium, we know because it's in group 2, we know its most stable cation is going to have a 2 positive charge, right? And so that we're looking for what could the charge be on element X, or the ion for element X, because that, once we have that, we can just match it up to one of these groups. Well, it's going to be one of these here because it's an anion. Well, you got to, because you're given the formula unit where the ratio is 1 to 1, the charge on element X, the anion, must be 2 negative. All right, so if you got 2 negative here, you crisscross these numbers to the subscript of the other element, and then you reduce. Then you get your original formula unit, which is CAX. So the answer to A is in group 16. And if you have an older periodic table, group 6A. All right, let's move on to B. So let's do the same thing. Magnesium, we know, is a group 2 element, so its most stable ion is going to have a 2 positive charge. Now we're looking for the charge of the ion for element X. That'll tell you what group it is. Now there's a subscript of 2 there and 1 there. So this 2 came from the charge on the magnesium. So this must also be, the charge on X must be 1 negative, because the ratio is 2 to 1 for that anion. So this is group 17, it's a halogen. X is a halogen, or if you have an older periodic table, 7A. All right, on to C. This time element X represents a metal cation. And notice, switch up the color here, and notice the subscript is a 3. Now let's start with the anion, because we're given that, and we know nitrogen, being in group 15, the most common form is going to, the most stable form of the ion is going to have a charge of 3 negative. All right, so let's put that there. So you can see that 3 subscript for element X must have come from the charge on the nitride anion. So therefore, since there's no subscript there, we just assume that to be 1, or that implies it to be 1. So this must have been a 1 positive cation. In other words, element X is from group 1. All right, move on to D. We're given the X is now the nonmetal anion, because metals are written first in these binary compounds and nonmetals are written second. All right, aluminum, and we have element X with a subscript of 3. Let's start with what we know, which is aluminum. And so that is a group 13 is going to, the most stable cation is going to have a charge of 3 positive. You can see that matches a subscript on element X. So element X must be a 2 negative anion, because that's what the subscript next to aluminum tells us, that 2 to 3 ratio. Okay, and you'll get that 2 to 3 ratio if element X forms 2 negative anion. So it's right here. This is group 16. or if you have an older periodic table, 6A. Let's see what color we haven't used. Let's go here. All right, we're on to E. X is now a metal cation with a subscript of 1. Fluoride, subscript of 1. So let's start with what we know, which is fluorine. It's the most common ion, is going to have a charge of 1 negative. And so that's a 1 there in the subscript of X. So we can say, in order for this to be a 1-to-1 ratio, the charges must also match. So this must be a 1 positive cation. In other words, it's a group 1 metal. Not hydrogen, but group 1 metal. It could be hydrogen if it was a covalent molecule, but it says it's ionic. So anyway, it's still group 1. Now, finally, let's go with gray. There you go. For F, X is again a metal cation, and that is ionically bonded to sulfur, which is group 16. So again, let's start with what we know. We know sulfur's most common or stable ion is going to have a charge of 2 negative, and because these are in a 1-to-1 ratio, the charge on the element X cation must be 2 positive, because if you have 2 positive and 2 negative, crisscross them, you're going to get X2, S2, which reduces to XS. So this must be a group 2 element.